Hello class. So today we're going to continue our practice on algebra, and today is the second lesson of algebra practice, and today we're going to be focusing on solving for x. And again, I know it's been quite a while since we've really done things such as solving for x, so that's again why we're doing this. Let's start off with the steps. So the steps here, there are really three easy steps. The first one, we want to simplify both sides if we need to. Now, I say if we need to because we won't always need to simplify. Sometimes it'll already be simplified. But just in case we do, we'll have to do that first. I'm going to put if needed. And then step 2, after we have everything simplified, we want to move all of the x's onto one side, and then all of the constants, or just numbers, constants are numbers with no variables, onto the other side. And it doesn't matter if you put the x's on the left, x's on the right, it'll be the same. Sometimes one way will be easier than the other, depending on the problem itself. So let's see, move all x's on one side and all constants. I'm going to write constants here. We should probably get used to using our math language. Just remember what it is. Constants to the other side. And then finally, step 3, solve for x. So as long as we follow these 3 steps in order, we should be good. It should give us a good framework of how to do these things. So let's take a look at a couple examples here. I guess more than a couple. We'll do a few. So first, let's start off with something like this. Say we have 5x plus 3 is equal to 18. Well, let's go through this by going through the steps. Now, yesterday we worked with simplification, didn't we? Simplify both sides. So let's check the left side. Is the left side here simplified? Yes. 5x plus 3, there's nothing more we can do to that side. Then we look at the right side. 18. Well, that's obviously simplified. So step 1, we're good. Step 2, move all x's on one side and all constants to the other. Well, we only have one x, and we have a constant here and a constant here. So what we're going to want to do is move this 3 over. So remember how we move numbers over when we're working with equations? We want to do the opposite operation. So here we have a plus 3, so the opposite operation of plus 3 is going to be minus 3. So we're going to subtract 3 from both sides, and hopefully that is familiar to us. And now this cancels, so let's just rewrite this thing. We have 5x is equal to 18 minus 3 is 15. And now we have all the x's on one side and all constants on the other side. And then finally, step 3, solve for x. Well, x is being multiplied by 5, so again, we want to think of this opposite operation concept. And the opposite operation of multiplication is division. So we're going to divide both sides by 5. That will cancel this out. So x is equal to 15 over 5, and 15 over 5 is just 3. Remember, fractions just mean division. So 15 divided by 5 is 3. And there we go. We solved for x on that one. Let's take a look at a different one, maybe slightly more challenging, maybe not, depending on how you feel about this. And that would be something that looks like this. We have 2x plus 1 is equal to 4x minus 5. So notice now each side has 2 terms. We have 2 terms on the left, 2 terms on the right. And let's go through these steps. So step 1, simplify both sides if needed. Well, just like with our first example, the left side is completely simplified. Remember, we can't combine constants with numbers with variables. And the same thing with the right side. That is also simplified as much as it can be. So let's go on to step 2. In step 2, move all x's on one side, all constants to the other. Remember I said it doesn't matter which way you move them to. I can move this 4x over here and this 1 over here, or I could do it vice versa, meaning I can do it the other way. You know what? I see here, if I move this 2 over, I'm going to be subtracting this 2. So it'd be 4x minus 2x, which will give me a positive 2x. If I were to subtract this 4x over here, 2x minus 4x, that'd give me a negative, and then I have to divide by a negative, which is okay. We can do that. It's just extra work. So what I'm going to do is I'm going to move this 2x over here. Subtract 2x. And this will cancel this out, which will leave us with 1 equals 4x minus 2x is positive 2x minus 5. And then finally we want to move this constant over, so it's being subtracted, so we want to add. So 5 plus 5x, or sorry, not 5x, just plus 5. And that will, oops, got my colors mixed up here. That'll cancel that out. So 1 plus 5 is 6, is equal to 2x. And then finally we can just continue solving for x. That's our step 3. X is being multiplied by 2, so let's go ahead and divide both sides by 2. And would you believe that? Look, our answer is the exact same thing, 3. I didn't mean to do that, but that's how it worked out. You know, I'm just going to use the same example to show you if I moved the 4x over here. And I just kind of want to make a point that, yes, we will get the exact same answer. And I just want to show you how it will look a little different and how it doesn't matter in the end which way you move things, whether it's one side or the other. So I'm going to move my 4x. So I'm going to subtract 4x because it's a positive 4x. That will cancel this out. 2x minus 4x is negative 2x. Plus 1 equals negative 5. Now remember, it's a negative because there's a minus in front of it, which it needs to carry down. And then we subtract 1 to move all of our constants onto the other side. That's going to cancel this. So we're going to have negative 2x is equal to negative 5 minus negative 1 is negative 6. And then finally divide both sides now by negative 2. So that will cancel this out. And remember, the negative divided by a negative, that's going to make a positive. We have to remember our rules there. If we're multiplying or dividing by the same sign, it's going to become a positive. So negative divided by negative becomes a positive. 6 divided by 2 is positive 3. And there you have it. We get the same answer regardless of which way we do it, as long as we do it correctly, right? Okay, let's do one more example here. And this one will require step 1, where we will have to simplify first before we can do anything else. Okay, let's say we have something like 2 times x plus 4 equals 3 times x minus 6. And so if you kind of isolate the sides, just look at the left side, this looks exactly like something we did yesterday, right? Or something like this. Exactly something like we did yesterday. So don't look at the bigger picture and get stressed out, okay? Just take it one step at a time. So step 1, simplify both sides. In this case, yes, it's needed. We need to simplify both sides here. So remember what we're going to do. We are going to distribute this 2 over here, and we're also going to distribute this 3 over here. So let's focus on the left side. 2 times x is 2x. 2 times 4 is 8, and it's going to be a plus 8 because they're both positive. Simplify the left side, awesome. Equals, now let's simplify the right. 3 times x is 3x. And 3 times negative 6 make sure you include that negative. 3 times negative 6 is negative 18 because we have a positive. This 3 is positive times a negative will equal a negative. And now we have something that looks just like our last example that we did, right? Where we need to move all of our x's onto one side and all of our constants to the other side. And again, it doesn't matter which way you do it, but I'm going to move this 2 over here because I'll be left with a positive x, which I don't need to divide by a negative. Just less chance for error, right? So subtract 2x from both sides. Remember, what we do to one side, we have to do to the other side. So that's going to cancel this out. And to rewrite it, we have 18 is equal to 3x minus 2x is just x, and then minus 18. And then we're going to want to add 18 to both sides, do the opposite operation to get our constants all into one side. That's going to cancel this out. And we're going to be left with x is equal to, well, 8 plus 18, what is that? 26. And there we go. Step 3 we don't need to do, solve for x, because notice x is already solved. In this case, it just happened to work out like that. So this is a lesson on how to solve for x. I hope it helped. And let me know if you have any questions. Thank you.